Some of my friends have been asking me how a 3D printing is done, and so I thought I'll make a quick video on the basics and just to show how the process is done. These are three of the printers that I have, and the red one that you see is the first printer that I built, and the other two are ones I bought a little later. And we'll start with this one because that's an exposed printer, so it's easy to see what's happening. On the side I have got a control panel. The control panel has got a knob to control the functions, and it's got an LCD display which gives us the basic information about the print job that's going on right now. The 200 degree that you see is the temperature at which the nozzle is extruding the filament, and you can see that the 49 is the 49 minutes that the printer's been running, and you have those details there. This is what it looks inside, and you have the power supply that regulates the power to the printer, and you have this is based on a Prusa design. It's the third iteration. I've taken the design from the Prusa i3 and modified it according to my liking. All these are parts that I designed and later on added according to the way I wanted the printer to work. And this forward and backward movement is the y-axis movement, and you have the x-axis rod horizontally and the z-axis vertically. And you have a set of motors. You have two motors for the z-axis movement, and there is you can't see the motor from here, it's behind there. That's the y motor, and the x motor is mounted on the x carriage, and this is the extruder motor which takes in filament, and the filament is pushed through a tubing which is the tension is held by two springs, and that's again a modification that I've done to the design. And finally it's extruded through a nozzle, and that's how the printing happens. And that is so this is the oldest printer that I have, and basically I use this printer to do all sorts of modifications, calibrations, and whenever I want to go deeper into the functions, then I work it out on this printer. And so this happens to be my favorite. Each printer has got a maximum built area. Maximum built area is the maximum size of the object that can be printed using the printer. And this particular printer has got 170 into 170 into 170 mm built area, which is defined by the maximum travel that the X, Y, and the Z can do. The small red circuit here that you see is the homing sensor. It's got a small sensor switch and some circuitry which tells the printer when it's pressed, it gives an information to the printer saying it's reached 0. This is the X carriage, so that would be X0, and this is the Z0, and behind the tray we have the Y0. And so first thing that the printer does before starting any print job is to home the axis, all three. So you get X0, Y0 and Z0, and from there the print starts. And the print is a series of commands which tell the coordinates that the head should travel to. So you will have for each and every moment you are being continuously fed coordinates, and each coordinate moves the printer in the X, Y and Z direction accordingly. And the printer prints layer by layer, and each layer is built one on top of the other, and the layer height is defined by the movement of the two Z-axis motors. And this particular printer that I've designed, it can go up to about 85 to 90 micron layer height, which would translate into 0.085 millimeter, which is thinner than the human hair, and it can go up to 300 to 350 microns, which is 0.3 millimeter layer height. And the lower the layer height, the higher the resolution. This particular print is happening at 200 micron, which is 0.2 millimeter. This is the second printer, and you can see that's a spool that is being loaded. This is a material called PLA, polylactic acid, and this is a biodegradable plastic. It's made from organic compounds. And what is being printed right now is part of the human skull, the calvarium region. And inside you can see something called support structure. Before moving to the next printer, I'll just briefly explain the support structure, the wall and the infill. The gray structures that you see, they are called support structures, which are built on from the bed to the horizontal surfaces. For example, you can see here you've got a support structure here. This being a horizontal area, unless there is something supporting it from the bottom, the printing cannot be done properly. So based on a set of complex calculations that you input, it calculates a support structure and makes support structures wherever it's required. And the blue part is the outer wall, and based on each print you define the thickness that you require for the outer wall, and since the printer prints at somewhere between 190 to 230 degrees centigrade, the material takes a while to cool down. So if the temperature is too high, it'll warp the print, and if it's too low, the layers don't stick. So for each print you'll have to find the optimum setting for that. And inside you have something called the infill. The infill adds strength to your structure, and the orange region that you see here is I'll zoom in a little bit. That is or the red region on the mobile. The red region that you see here is the infill, and the infill density defines the strength of the model. So if you want a very strong model, you have more infill, and if you want it just as a one-time prototype, you go lesser infill. Another thing about the infill is if you make it too dense and if you print too fast, again that will lead to warping and deformation of the model, because since you're printing at a high temperature, the whole heat buildup can cause problems to your print. So now we'll go back to the printer and I'll show you the infill support structure and the walls. So here you can see the infill pattern, which is printed right now. It's printing the infill, and you define a percentage for the infill. The higher the percentage, the more dense the infill is. So each layer, when it's printed, this is the support structure that's being printed. And how the printer works is each layer prints an infill layer, a support layer, and an outline layer. The outline defines the thickness of the outer wall. And once that layer is complete, the z-axis goes up by whatever layer resolution you have set. For example, if you have set 100 micron layer resolution, the z-axis will move up by 0.1 millimeter, and then it builds one layer after the other and completes the print process. And these two printers are controlled by a single Raspberry Pi, which sits here. Which is wirelessly connected to the router, and the advantage being the print files, the models we printed, all that can be uploaded centrally from anywhere with web access, and both the printers can be controlled remotely for changing the filament, heating, and whatnot. And here we have the third printer, which again is controlled by another Raspberry Pi, which is again wirelessly connected to the router. This particular printer is a dual head printer, which means it has two extruders, and it can print in two different colors at the same time. This printer has a different travel mechanism. Here the z-axis starts at the top, and as the build progresses it keeps moving down. And it's a dual head printer, which means you can print two colors at the same time if you need to. And I've removed the top cover so you can get a better look at the printer. The bed remains completely stationary other than the Z movement, which is once after each layer is complete. Now here is the centralized management console for the two printers. So this is basically a Raspberry Pi running Raspbian Linux, onto which I've installed something called the Repeater server, which lets you connect multiple printers to the same Pi via USB and through the Wi-Fi network. So if you want to get into the printer, you can do so. And here you have a list of files that you've uploaded, and if you want to see the real-time status of the print, I can connect a webcam to the system, but right now it's disconnected, or I could show you the video. This shows you the built platform. That's the support structure, the infill being printed, and it will show you the information on how long the print will take, and the layer height, and other details, and the progress bar. And you have the list of printers here, and you can choose whatever print that you want to. The advantage I see with I've used multiple print server systems, and the advantage of the Repetia server that I see is I find it much more clearer, and everything is very crisp and precise, and it also renders a preview quite well. And for the other printer, I use something called the Astrobox, which is another printer system, which again runs on a Linux platform. And Astrobox has got a different interface, and the reason why I am using Astrobox here is because the third printer works on a different file system called the X3G, and X3G is not supported by Repetia host, so I have to have these two separate files. I assume that Repetia is going to support X3G in the future, and I can have all the three printers hooked onto the same file. So that's basically it, and that's me signing off.